Today we're doing section 4.5, day 2, and we are going to get into more difficult examples of graphing the sine wave. So for our first example, we have y equals sine of 2x minus pi. So my a value is implied to be 1, so if you need to write a 1 there. My b value is 2, and my c value is pi. So remember that your c value is always the opposite sign. So my amplitude is 1. My starting point is c over b, so pi over 2 for my starting point. My period is 2 pi over my b value, so my period is pi, and the distance between each x value will be pi over 4. So notice we are now shifting, we're no longer starting at 0. My starting point is pi over 2. And now, each time, we are adding a distance of pi over 4. So for my x2 value, I'm taking pi over 2, and I have to add a pi over 4. So to get common denominators, we need to change that first fraction to have a denominator of 4, so I can change this to be 2 pi over 4. So now I have the common denominators. So my x2 value will be at 3 pi over 4. And then I'm going to continue to add pi over 4. So 3 pi over 4 plus pi over 4 will be pi, which is the same thing as saying 4 pi over 4. If I add another pi over 4, I'll be at 5 pi over 4. And lastly, we'll finish off at 6 pi over 4, which reduces to be 3 pi over 2. And now that I have all this information, the last part of this is to get it all onto the graph. So my x1 value is no longer at the origin. My x1 value is now at pi over 2. Because it's a sine wave, it will still be at an intercept. My next value is 3 pi over 4. So we got to kind of think common denominators here. Pi is like a 4 pi over 4. This is like a 2 pi over 4. So 3 pi over 4 would be dead smack in the middle between these two. And my amplitude is positive, so it will be at a maximum of 1. At pi, we're back down to an intercept. Again, this would be like my 6 pi over 4, which means my 5 pi over 4 would be dead smack in the middle between these two at a minimum of -1. And then we're back up to an intercept. And let's just keep going for the sake of understanding how this pattern works. So I would just keep continuing this pattern on. And now I can graph 2 full periods of the sine wave. And then we just connect my dots. So notice the wave just keeps going and going. If I wanted to go in the negative direction, this point would be here, and then we would be there. So the domain will be negative infinity to positive infinity, and the range would be -1 to 1. And apparently I can't count on that one. That should be down there. You get the idea though. Alright, so let's try another one that has some phase shifting, as we call it. So here we have sine is x over 3. So a is 1, b is 1 over 3. I have 1/3 of x. C is 0, and d is 0. So amplitude is still 1. My starting point is c over my b value, which is 1/3. So starting value is 0. The period is 2 pi divided by b. So 2 pi divided by 1/3. We keep change flip. 2 pi times 3 will become 6 pi. And then my period over 4 will be 6 pi over 4, which we can reduce to be 3 pi over 2. So my x1 value is my starting point, which in this instance is 0. And now I'm adding 3 pi over 2 each time. So this will be 3 pi over 2. The next point, 3 pi over 2 plus 3 pi over 2, would be 6 pi over 2, which is 3 pi. So remember, that was a 6 pi over 2. So 6 pi over 2 plus 3 pi over 2 would be 9 pi over 2. Plus another 3 pi over 2 will put me at 12 pi over 2, which would be 6 pi. So this one is really stretched out. This is a really stretched out sine wave, and we're only going to have room to do one period on my graph. X1 value is 0, so there is my first value. My X2 value is 3 pi over 2, so 3 pi over 2 with a maximum of 1. Then we go to 3 pi, and we're back to an intercept. Then we go to 9 pi over 2 down to a minimum, and 6 pi back up to an intercept. So very stretched out sine wave. So notice your B value determines how stretched or shrunk the wave is for the period. As far as the domain and range, we haven't really seen too many different pictures. The domain is negative infinity to infinity, and the range is still negative 1 to 1. So that's all for today.